Hey folks, let's take a look at the graph of a secant transformation. The first thing we do is find the guide function. So the guide for secant is its reciprocal cosine, so we just replace those. And then we're going to find the 5 characteristics for this guide function. So we read left to right, fill in our 5 characteristics. We see a negative. So negative means that yes, there is a reflection. The amplitude is the absolute value of the leading coefficient, so that's 1. The period for a sine or a cosine is 2 pi unless there's a modified coefficient here. So period will be 2 pi. The phase shift, if we don't have a leading coefficient other than 1 here, then the phase shift is the opposite of what we see right here. If there is a coefficient, we have to take this and do the opposite of c divided by b. So here, pretty straightforward. It's just the opposite of pi over 2. And then the vertical shift is last, -1. So this tells us that the first period for cosine is going to start at the phase shift. So for sine and cosine, we start at the phase shift. So that means -pi over 2 is going to be the left endpoint of the first period. Now to get to the right endpoint of the first period, we can add the period. So if we take -pi over 2 and add 2 pi to it, we will get 3 pi over 2. Now another way to do this is to put x plus pi over 2 in between 0 and 2 pi, subtract pi over 2 from both sides, and that's another way to get to these endpoints of the first period. And then we're going to put in some tick marks here so that we have 4 quadrants essentially. And this one will be at pi over 2, and this one will be at pi. Now, if it wasn't as obvious what these intermediate points would be, you would have to do a little math. 2 pi divided by 4 is pi over 2. So I know that I'm going to do an addition of pi over 2 3 times to get, or 4 times to get over to the right. So -pi over 2 plus pi over 2 is 0, 0 plus pi over 2, pi over 2 plus pi over 2, and pi plus pi over 2. So if the interval was a little more complicated, you could do a little bit of arithmetic to get to those markers on the x-axis. Okay, so now what we're going to do is toss in our vertical shift. Our vertical shift. So our vertical shift, I'm going to stretch this out a little bit and put it down here just so that my numbers aren't making a total mess. So our vertical shift, down 1, this is going to give us what I refer to as the center line. And now what we're going to do is plot our key points. Now we know that the basic shape of cosine looks like this. There's the basic shape, and there are 5 key points right there. And the center line goes right through those 2 key points. So that's what a basic cosine looks like. Now, this is a transformed cosine. We have a reflection, so that means that these key points here are going to bounce down, and this key point is going to bounce up. So if we come over to our center line here, instead of being up at this point, we are going to be down 1 unit here at -2, and we're going to be, instead of being here, we're going to be down on the right, and in the middle we're going to be up, and then we form this. If it's not reflected, it's a V. If it is reflected, it's an upside down V. And so here is a picture of the first period. That is not very nice, but you know what I mean. So that is the first period of this transformed cosine. And now if we want to finish off and graph the secant, the transformed secant, what we're going to do is find the asymptotes, and we are going to then fill in the blanks. So the asymptotes are going to be where the center line is crossed. So those are the asymptotes. And then we fill in the blanks. We put a curve right here. And we're going to put a half curve right there and a half curve right there. This will be the first period of the transformed secant. Now the domain of this function, the domain, let's say the domain of f, domain of the function, is all real numbers except x cannot be an asymptote. So we have to figure out where the asymptotes are. And what we see is that the first asymptote is right here at 0, and then we add pi radians to get to the second asymptote. So that means that they're going to be pi apart. So x cannot be equal to pi times k. When k is 0, we're right here. When k is 1, we would have x equals pi, which would be this asymptote. If k were 2, we'd get to the next asymptote to the right. If k is -1, we'd be at this asymptote over here. So that will be the domain. And let's, for good measure, put the range of the function. The range is the set of y values that the function uses. Well, it starts way down at -infinity, comes up the y-axis and stops at -2, but it includes -2, so we put a bracket. And then we have no y values in this window right here from -2 up to 0. And then the y values resume, so we will go from 0 to infinity. And that will be how we graph a transformed secant.